Let us see question number 16. Z transform of a to the power of n x of n is equal to a x of z by a, b x of az, c x of a by z, and d x of 1 by az. The answer is a, that is x of z by a. Let us see question number 17. Z of x of minus n, that is z transform of x of minus n is equal to x of 1 by z, x of az, x of minus z, and x of z square. The answer is x of 1 by z. So, that is z transform x of minus n is having a z transform which is equal to x of 1 by z. So, the answer is A. Let us see question number 18. The z transform of x of n plus n naught is given by a z to the power of minus n naught x of z, b z to the power of n naught x of z, c z of x of z, and d 1 by z x of z. So, this is derived from one of the properties of Z transform. So, if you understand the Z transform properties thoroughly, then answering these type of questions is very easy. So, the answer is B, that is Z to the power of n naught x of z. Now, let us see the 19th question. The Z transform of a unit step function is A z by z minus 1, b 1 by z minus 1, c 1, and d 0. As you are aware, we have done a lot of problems on this type of questions. So, answering this question will be really simple, and the answer is A, that is z by z minus 1. Okay, the Z transform of unit step function is given by z minus 1. So, the answer is A. Now, let us see question number 20. The Z transform of a unit impulse function is A z by z minus 1, b 1 by z minus 1, c 1, and d 0. It means you have to find out what is the Z transform of a unit impulse function, also called as delta of t. So, what is its Z transform? A z by z minus 1, b 1 by z minus 1, c 1, and d 0. The answer is C, that is 1. So, a delta function, when you take a Z transform of it, you will get a Z transform which is equal to 1. So, you can see the similarities between this type of questions and the Fourier transform also we have done similar questions. So, you have to be a little careful and also understand the similarities between how we have done Z transforms there, how we have done Fourier transforms there, and how we are doing Z transforms here. So, the answer is C, that is impulse function transformation in Z domain is equal to 1. Let us see question number 21. The Z transform of unit ramp is z by z minus 1 whole square, that is A, choice B is z by z minus 1, choice C is 1 by z minus 1, and choice D is 1. So, unit ramp function, what is Z transform? So, unit ramp function is like this, as you all know, unit ramp function looks like this. So, this is a unit ramp function, and we have to find out what is the Z transform of this type of function. A z by z minus 1 whole square, or B z by z minus 1, or C 1 by z minus 1, or D 1. The answer is A, that is z by z minus 1 whole square. Question number 22, let us see. The Z transform of delta of n plus k is A z to the power of k, B z to the power of minus k, C z to the power of minus 2k, and D z to the power of plus 2k. That means the Z transform of delta of n plus k. What is the Z transform for it? A z to the power of k, B z to the power of minus k, C z to the power of minus 2k, and D z to the power of 2k, and the answer is A, z to the power of k. Let us see question number 23. If x of n has a Fourier transform x of z, then according to initial value theorem, x of 0 is equal to what? Okay. A, limit z tends to 0 x of z, B, limit z tends to infinity z of x of z, C, limit z tends to infinity x of z, or D, limit z tends to 0 z of x of z. So, if you remember the initial value theorem studied earlier, then we will know that the answer is nothing but C, where limit z tends to infinity x of z is the answer. Let us see question number 24. If x of z is equal to z by z minus a plus z by z minus b, and z lies between a and b, then x of n is equal to a a to the power of n u of n minus b to the power of n u of minus n minus 1, b a to the power of n u of n plus b to the power of n u of n, c a to the power of n u of n plus b n to the power of u of n minus 1, and d a to the power of n u of n minus 1 plus b to the power of n u of n minus 1. You see here z by z minus a is a to the power of n and it is u of n because z is lying between a and b. Second is b of n u to the power of minus n minus 1 because z is less than b. So, it will be answer A, that is a to the power of n u of n minus b to the power of n u of minus n minus 1. So, the answer for 24th question is A. Let us see question number 25. Complex exponentials are Eigen functions of dash systems. A. Linear time variant systems. Choice B. Linear time invariant systems. Choice C. Time variant systems, and D. Non-linear systems. And the answer is B. Complex exponentials are Eigen functions of linear time invariant system, and the answer is B. Let us see question number 26. The inverse z transform of h of z is equal to x of z y of z is A. X of n y of n, B. X of n convolved with y of n, C. X of n d y of n. So, in inverse z transform of h of z is x of z and y of z, that is the product of x of z and y of z. So, inverse z transform must be convolution of the same functions in end. Okay. So, that means the answer is B, that is x of n convolved with y of n. So, the answer is B. 27th question. 27th question is that z transform of x of 0 is A. X of z, B. Limit z tends to infinity x of z, or C. Limit z tends to 0 x of z, or D. X of 1. So, x of 0 is basically initial value theorem. So, you can say the answer is B, that is limit z tends to infinity x of z is the answer for the 27th question. Answer is B. 20th question is the inverse z transform of x of z is equal to 1 by 3 by 1 minus 1 by 3 z of minus 1 mod z is greater than 1 by 3 is A. 1/3 n plus 1 u of n, B. 1/3 n u of n, C. 1/3 n minus 1 u of n minus 1, and D. 1/3 n. So, answer is A, that is 1/3 n plus 1 u of n. That is the question number 28. Let us see question number 29. If x of n is having a z transform of x of z, then n of x of n will have a z transform. The choices are A. Minus z d by dz of x of z, B. Minus d by dz of x of z, C. Z of d by dz of x of z, and D. d by dz of x of z. The answer is A, that is minus z d by dz of x of z. Let us see the question number 30. If x of z is equal to a z to the power of minus 1 by 1 minus a z to the power of minus 1 whole square, where z mod z is greater than a, then x of n is equal to how much? Okay. So, inverse the transform. A is a to the power of n u of n minus 1, B. N into a to the power of n u of n, C. A to the power of minus n u of minus n minus 1, and D. A to the power of n u of n. And the answer is C, that is a to the power of minus n u of minus n minus 1.